Welcome to NumPy arrays and random data for time series. In this lesson, we will start with basics and move towards using real datasets. NumPy helps us handle collections of numbers, especially for time series data. Let us see how these ideas connect to real-world problems. Running the cell now. This imports a library to hide unnecessary warning messages. It helps us focus on learning without extra distractions. Running the cell now. Try typing these lines and notice there are no warnings. Here we are bringing in the NumPy library. NumPy is a popular tool that makes math and data handling much faster. Running the cell now. You will see import statements at the top of most Python data notebooks. What is a NumPy array? A NumPy array is like a list, but better for math and big datasets. Arrays can store lots of numbers in a single object. We will build and explore some arrays next. Running the cell now. Now we will create our first NumPy array. The array holds a bunch of numbers together. Printing the array shows us its values. Running the cell now. Try changing the numbers and see what happens. NumPy arrays behave a bit like Python lists. We access elements by their position. 0 means the first item. -1 means the last item. Running the cell now. Try picking some other positions. Why not use regular Python lists? NumPy arrays are faster and use less memory. You can do math on whole arrays at once without loops. This is very important for time series datasets with lots of data. Running the cell now. Math with NumPy arrays is simple and fast. Adding a number updates every value at once. There is no need to loop through items like with regular lists. Running the cell now. Try subtracting, multiplying, or dividing the whole array. Let us inspect our array a little more. The first call tells us if it is a NumPy array. The second line shows the type of value stored. The third line tells us how many items there are and the size. Running the cell now. Exploring shapes is important for working with real data. NumPy can quickly make arrays filled with zeros. This is useful for setting up empty data. You can also create arrays of random numbers for testing and simulations. Running the cell now. Try using different numbers inside zeros or random. We can make random whole numbers easily. Here we ask for numbers from 1 to 100. This helps when we need lots of test data quickly. Running the cell now. You could use this for games, experiments, or practice problems. Here we build an array with numbers 1 to 6. We reshape it into a table with 2 rows and 3 columns. Reshaping is very handy when data moves from a list to a table. Running the cell now. Try reshaping to different sizes and see what is possible. Slicing lets us grab several items in a row. Here we ask for positions 1 up to, but not including, position 4. Running the cell now. Try slicing with other start and stop values. Handling errors safely. Sometimes you might try to get data that is not there. Let us see how to safely access array values and catch errors. Running the cell now. Here we demonstrate what happens if you ask for a position outside the array. Python will normally show an error. By wrapping it in try and except, we can print a friendly message instead. This technique is helpful in real programs where input might be wrong. It keeps your program running instead of stopping with an error. Running the cell now. Practice by intentionally making an error and catching it. Data setup. Now let us work with a real dataset. We will use the shampoo sales data, which is monthly sales in thousands. Let us load it and peek at the data. Running the cell now. We are loading pandas, which works well with tables. Now we download the shampoo sales data from a web address. We load it into our notebook using pandas. Printing the shape tells us how many rows and columns the data has. Printing.head shows us the first few records for a quick preview. Running the cell now. Try using .tail to see the last 5 rows of the data. Now let us see how sales change over time. We import matplotlib for plotting charts. We make a figure using a bigger size for visibility. We plot only the sales numbers for clarity. The title and labels explain what we are plotting. Finally, we show the chart below our code. Running the cell now. Try changing the figure size or labels for practice. Now we will pull just the sales column out of the data frame. We convert it to a NumPy array. This is useful for math operations. We print the type to check it is an array. Then we show the first 10 sales numbers. Running the cell now. This step is very common in real data workflows. With NumPy, we can get the mean, minimum, and maximum values easily. The mean is the average sales. Minimum is the smallest sales value. Maximum is the largest sales value. Running the cell now. Try looking for the standard deviation with np.std. Normalization rescales numbers to make comparisons easier. Here, each value is shown as a percentage of the highest sales. This is often useful for seeing trends when numbers are very different. Running the cell now. Try plotting normalized values on a new chart for practice. You can use NumPy where to find the positions of high sales months. Here, we check which months had sales above 350. This is useful for highlighting special cases or outliers. Running the cell now. Modify the number to find other interesting months. Let us pretend to make our own sales numbers, similar to the real data. We set the random seed for reproducible results. We ask for 24 sales numbers, with average 300 and some variation. This sort of simulation is great for practice and testing. Running the cell now. Try changing the average, LOC, or the size for different results. Here, we compare real sales data with the fake data we made. We plot both lines on one chart using labels. Adding a legend shows which line is which. This helps us see patterns and differences easily. Running the cell now. Try changing the number of fake sales points, or adjust the chart style for practice. If this is helpful, subscribe for more lessons on data science. It is important to follow best practices in your code. Set random seed so outcomes are the same each time. Check the shapes of your arrays before you calculate. Labeling helps others, and future you, understand charts. Running the cell now. Following habits like these saves lots of confusion later. Sometimes you try to add 2 arrays that do not match in length. NumPy will show an error if the sizes are not compatible. Using try and except helps catch these mix-ups with a clear message. This saves time and helps prevent bugs in data work. Running the cell now. Deliberately make an error and catch it for practice. You can interact with users in notebooks using input. Here, we ask for a sales number. We convert the input to a floating point number for safety. Printing confirms what was entered. Running the cell now. Try entering different values and see what happens. This challenge filters just the top months by sales. We select only those sales bigger than 300. Then we calculate their average. This is a powerful way to drill down into your data. Running the cell now. Try changing the filter to experiment with different thresholds. Recap. Today you learned about NumPy arrays, random numbers, how to load and plot a real-world time series, and how to make your own synthetic data. You practiced best habits and saw some troubleshooting tips. Keep exploring these basics. They will help in any data science project. Running the cell now. Thank you for learning with us. Go try out these codes in your own notebook. Like and subscribe on YouTube for more friendly Python lessons. Running the cell now.